Hello everyone. In this video, we are going to discuss about semaphores. Now, what do we mean by semaphore? Semaphores are nothing but they are tools used for process synchronization. They are a very effective process synchronization tool, and they are implemented through the very simple concept of variables. Right? A simple integer variable can be used as a semaphore for achieving process synchronization. Now, let's move on to the definition of a semaphore. A semaphore is a special kind of synchronization data that can be used only through specific synchronization primitives. So, as I already informed you, semaphore is nothing but it is a synchronization tool which is used for achieving process synchronization. And how is that process synchronization achieved? That can be achieved only with the help of special or specific synchronization primitives. Right? These specific synchronization primitives are nothing but they are the operations that can be performed on a semaphore. So through the help of operations on the semaphore, we can achieve process synchronization. Now, when a process performs a wait operation on a semaphore, the operation checks whether the value of the semaphore is greater than 0. Now, as I already informed you, this is talking about the specific synchronization primitives. These specific synchronization primitives are nothing but they are the operations that can be done on a semaphore. So, what are the operations that you can do on the semaphore? We can do two operations, and one of the operations is nothing but the wait operation, which is mentioned here. So whenever a process is going to perform a wait operation on the semaphore, then what will that wait operation do? It will check whether the value of the semaphore is greater than 0. Then coming to the next operation. The next operation is called as the signal operation. So whenever the signal operation is executed on the semaphore, it means the value of the semaphore has to be incremented. That is, whenever a process finds out that the semaphore is greater than 0, then automatically the value of the semaphore will be decremented and the process will be allowed to execute. Otherwise, the process has to be blocked on the semaphore itself so that another process who is already executing will not permit this process to enter the critical section. I hope you're able to clearly understand the meaning of the wait and the signal operations. See, the semaphore is nothing but an integer variable. Let's say I'm assigning a semaphore value as 1. Okay. Now, whenever wait operation is executed on the semaphore value will be checked. It will check whether the semaphore is greater than 0. If it is so, the value of the semaphore will be decremented. That is, S, which was 1, will now become 0. And once it becomes 0, it will enter the critical section and it will start executing in the critical section. But if the value of the semaphore was already 0, then when the value of the semaphore is decremented, it becomes 1, which means it cannot enter the critical section. So the process has to block itself because some other process is already running in the critical section. So that is what is meant by the wait operation and the signal operation. So as I already mentioned, signal operation on a semaphore will activate the process which is blocked on a semaphore, and it just increments the value of the semaphore by 1. So due to these wait and signal semantics, semaphores, you call them as also counting semaphores. The initial value for semaphore will always determine how many processes can get past the wait operation. Now look at this code given here. See, this P indicates the wait operation. This V indicates the signal operation. P is the wait operation, V is the signal operation. As already mentioned, wait operation, what will wait operation do? It will check the value of the semaphore, and if the value of the semaphore is greater than 0, value of the semaphore has to be decremented. Okay, and if the value of the semaphore happens to be equal to 0, then the process will be waiting on the semaphore until semaphore becomes, as long as semaphore is incremented. So what happens whenever the semaphore value is 0, you see a semicolon after the while loop. This indicates that the process will get blocked in the while loop itself, thereby preventing it to enter the critical section. Why does a process block itself? The reason is some other process is already executing in the critical section, and hence this process will not be allowed to enter. When will this process be allowed to enter? If a signal operation on the semaphore, that is the V operation on the semaphore, is executed. What is meant by the signal operation? Signal operation is just used for incrementing the value of the semaphore. So whenever a process leaves the critical section, the semaphore value will automatically be incremented. So when it becomes incremented, automatically the lock which was put here will be released, and that particular process which was locked in the while loop will now be able to enter into the critical section. So this is how semaphore is used to implement process synchronization. And that's why we say that semaphore is a very simple and easy synchronization tool with which process synchronization can be achieved. So now we move on to the different types of semaphores. There are two different types of semaphores. One is the binary semaphore and the other is the counting semaphore. What is meant by binary semaphore? A binary semaphore is also known as a mutex lock. That is, it can have only two values, either a 0 or a 1. So always a binary semaphore is initialized to 1. Now it is the purpose of a binary semaphore is used to implement the solution of critical section problems when there are multiple processes. Now coming to the next type of semaphore, which is called as the counting semaphore. A counting semaphore value will range over an unrestricted domain. That is, it can be any integer value. It can start from 0 and it can go on up to n. So that is called as a counting semaphore. And where is it used? It is used to control access to a resource that has multiple instances. So with this, we end the different types of semaphores. Thank you.